Hello.
Yeah, hello.
Okay, okay, okay. Niranjan sir, start பண்ணலாம் sir. Sir, Niranjan sir, start பண்ணலாமா? Okay, okay. ஸ்டார்ட் பண்ணிடுங்க.
Hi and hello to everyone. Good morning to all. So, first of all, I want to thank the organizer, Mr. Shankar sir, the convener, Mr. Pushpraj sir, and the principal, Mrs. Arpada Vijay Selvi, for giving this opportunity on presenting this crucial topic to budding engineers of our college. And myself, Gunashekharan Karthikeyan, and I'm going to give a topic on the product sustainability and reverse engineering. So, next slide, please.
Sir, yeah, very good morning. Sir, shall I give an introduction, sir?
Yeah, please.
Yeah, yeah, very good morning to everyone one and all present here. It is such an honor for me to get the opportunity to deliver the introduction to the research work. Now, person is Mr. Karthikeyan. He has completed PG Engineering Design at PJ Institute of Technology, Chennai in the year of 2022 and he completed UG Mechanical Engineering and Scholarship of Engineering Tanjavur of 2008-2012. He has completed the school in Government Subramanian engineering, then technical he was engineer in he was as a proposed safe batch private limited Chennai. And from the year of 2000 to 2013, he was worked as a team leader at Toyota Shusho Assembly India Private Limited, Chennai. He was recognized as the innovator and rewarded by the HCL Technologies. And also he received the award of exceptional performer by the HCL Technologies. And he received the many awards for a debate, poems, and the paper presentation for the various symposium and the different colleges. And I extend a warm welcome to the resource person, Mr. Karthikeyan Gunasegaran, and the people in the gathering. I welcome, sir.
Thank you, sir. Thanks for the warm welcome. And
Thanks.
with that, I would also like to extend my thanks to all the faculties and King's College organization for giving us this opportunity. Um, with that, I think I can move on to the session. So, can you go to the next slide, please? Shankar sir, have you changed the slide? Yeah. So this topic about is product sustainability. But before going to that, we need to know what is the product sustainability and where does it comes into play. And before starting this session, I would like to have a word on. I would like to apologize first because I'm not able to share the screen since I have a constraint on using office laptops here. So I'm presenting through the mobile phone, and if there is any hiccups, sorry for that as well. So moving on to the topic, this is about the product sustainability and this is about product life cycle. So what is the product life? Everything that we deal here is on a product to product basis. Like we design a concept, we develop a prototype, we test it, we manufacture it, we distribute it, we service the product, we recycle it, and we dispose it. So this is what a product life cycle is all about, and this you can find it in any product that you use in your day-to-day activities. Shankar sir, next slide, please. Second slide. You can go to the next slide, sir. Third slide. Yeah. So this is how a PLM works. This is categorized. The PLM product lifecycle is categorized into two phases. That is, one is innovation phase and another one is the commercialization phase. Now, we as a design engineer focus on the innovation phase, and the commercialization is a part where the organization plays its crucial role on marketing, establishing a patent, establishing a product to the product such that they can be distributed and they can be a mass gain, a profit can be used obtained from them. Now in our role, what we do is we do an innovation. Uh, we depend on the inputs that we acquire from the requirement of the customer. Everything is a customer end-to-end basis. We design a product for the benefit, for the use of the customer, so their requirement is must, which is an input for us. Based on that, we come up with a design. On based on those designs, we program a management, or we establish a program such that our product can be developed, they can be prototyped, they can be established into testing, and then verification has to be done for those activities of the product, whether the desired input and output are met or not. And then we have to make sure that we are meeting with the regulatory compliance as per the governmental bodies. And then we have to propose this everything to the um, organization, and there they will be coming up with a strategy to make this commercialized. In that process, they will work on publications and customer service and repairs, spares, everything comes into those place. So this is just a general idea of how the product lifecycle management works in overall. Shankar sir, can you move to the next slide? Next slide, sir. Not this one, sir. Before that. Yeah, this one. So this is how a product is manufactured or produced or designed based on a quality management. The first phase is a concept phase. The second is a product design. The third is a process design. Fourth is a production. This is the phase where we as an engineer come into play, and based on the input from the customer requirement, we develop a concept, and based on that concept, we work on the function failure, we establish the function failure problem, and based on the feedback from the customer, we design a product, design a prototype, and then the prototype is mass produced through a process design, and then it goes to the production. Now if you can see at the right side of between the service and the feedback, there are three categories, and those are function, failure, and problem. Before designing a concept, we must understand what is the function of that product. If I require, for example, my need is to write, what do I need to write? A pen or a pencil is need to write. So what is the function? It has to write. And next, where can it be failure? During the holding of the pen, or during the when you are using any ballpoint pen, it might get leaked up. So those are the failure points of that particular product. So this has to be categorized by us. We have to define which where the product can go into failure mode. So that is where the failure mode effect analysis comes into play, and then the risk factors play. And what is the problem? How is that failed? So this and all has to be established so that the product design concept can be at a better phase. Then comes the product design. We design a product. Now we have in product design, we make a 3D, we make a 2D, then we make a prototype on that 3D printing machine or any other manufacturing method, and we make a prototype of that product. Now what happens is next we go on the process design. The process design is a phase where the product is from the prototype, it is going into the mass production. For in between the mass production and the prototype, the process of taking one product to a multiple is known as the process design. So for that process design, for single product to come into a mass production, many lines and units of production plants are required. So many manufacturing machines, automatic machines, milling machines, grinding machines, many such machines are required, where which are validated to meet the actual production requirement of that product. So that is where the process design comes into play. Now, while establishing a machine, it can possibly go into error due to method or material. The product or machine can face any error at the any point of life. So a we have to validate the machine before going into a production phase. So the validation of IQ, OQ, PQ, that is input qualification, output qualification, and process qualification is required. So based on this qualification methods, we establish a machinery that will produce our product in mass values. So that is what this process design comprises of. And then we go into the production phase, that is based upon the final endpoint where the product is produced. After production, then the product is marketed and commercialized into the market, and then a post market surveillance is taking place to get the feedback of how the product is working and how we can initiate the we can have a better product to meet the customer's requirement. So these are how the quality plays into check for each of design criterias that we all face, that we have all the products in. Now let's move on to the next slide. Shankar, the next slide, please. So far I have said that what is a product lifecycle management is, but why do we need a sustenance into the product? What is the sustainability need for this product lifecycle management? As you can see there, we develop a product which is a ready product or which is a newly designed product. Next, we introduce it to the market. That is, then the customer growths come. We build a brand, we price and distribute the product, and next we gain a profit from those product established into the market. And the competitors may copy us or may not copy us. They can give the relevant products, they can give equivalent products. Something can happen in the market. Due to that, our product can reach a top peak, or it may diminish based upon our products efficacy of our product. It is established. Now the maturity, what happens in maturity means that's the point where our product goes into a peak. The growth is exponential. The market then saturates as it is. The product that we provide to the market, that the customer uses it, they are already convenient with it, but they need more, because we as a human, always have a tendency to need more from what we have. We are not contented with what we have, and that is the biggest drawback, I would say. But in engineering point, that is what gives us more opportunity to explore our products into the market. By maturity, next comes the declination period. This is where the product already provided to you diminishes, and the market is lost, and the brand has no value. You can see many products like many brands that has been established before are not in existence now, but they are in existence as in a separate or new brand or new name. They establish it and they come up with a new innovative product to develop their market. Only few products in the market are like that, which have a long sustaining values, and people depend on it. For example, a car, Maruti 800 was there before, but now it is not there, because the need that the Maruti 800 provided to a customer at that point of time is not required at this point. Now the consumer need a car with fuel efficiency, safety, everything is counted for. Now the Maruti 800 doesn't produce it. So what are they going? They're going with a new product. They're making many versions of that. But the initial phase that they came up with was Maruti. Now it has been improved. The improvement is known as new product development, which is achieved by the sustainability of that product. So this is where the sustainability comes in. So once we produce a product and we establish that into a market, we should not leave it as it is. We have to get a customer feedback service. We have to get their inputs, and then we have to improve the design of that particular product such that we can sustain in a market for minimum of 10 to 15 years. For example, if I am producing a product and it costs me around 1 crore or 1.5 crores, and I'm distributing in the market, I'm gaining a profit of 5 crores. What happens at the end of first year or second year? The consumers all get used to that product and they get bored of that product. It stops continuously. So the entire effort of production that I have inputted for this will be lost for me. So my total gain will be around 7 crores, and my input that I have put into the value of that is around 9 crores. So I will be at a loss at end of 2 years. So to achieve that, to eradicate those losses, I have to sustain in a market with minimal changes in design and also application of design, so that I can make a profit from that particular product for a long term. So that is where the sustainability of a product comes into play. So next one, can we go on to the next slide, sir? So this is how a sustained product development works. First, we have to understand what does this sustainability product development means. It means a working product is a working product at all the time. A product is working to the requirement of the consumer. Next, there is a continual re-engineering or a reverse engineering of a project or particles. Project should be practiced for that particular product. So based on the feedback from the consumer. Next, the based on the practices that we do and as a reverse engineering or a re-engineering, we should come up with a modified design that should accommodate the current need of the consumer. And next, if by changing our product design, are we facing any defect, or is the efficacy of the product is diminished, or the safety of the user is implicated, is what we have to ensure. Next is the functionality and features innovation. Everyone goes for aesthetic values, but they don't go against the safety for an aesthetic nowadays on every product. So we have to give the functionality of the product with by adding the aesthetic, and also giving more rigid and sturdy design to accommodate the feature of the product without compromising the efficacy to the consumer. Next, if a product can be collaborated, that means I have one product and I have already established in the market. Now I have a chance of making a small change to the current product that will give me a not only single output but double output, such that by combining two in a single modification on one product will provide us a double output as in a customer requirement. For example, I'm writing with a pen. Now I am writing with a pen with a ballpoint. So assume that I'm just making it, there is one ballpoint pen at a color of black. I'm adding another feature of multiple rotation ballpoint pen, so that I can accommodate not only one color, 5 colors I can accommodate in a single pen. This is for a ballpoint. Now in the same process, you might have seen a Parker pen which accommodates both ink and lead. So like this, a small twitch in the design can accommodate two outputs, is what we, as a collaboration, we mean it. When you see in our manufacturing stream, earlier it was only fuel manufacturing. Now they are giving a hybrid. So in the same engine, they are also working on with a electric vehicle as well as a fuel injection vehicle. So this is the output body is all the same. They are working on the engine to modify it, and they are giving a two output, which is also cost effective, which is also safe. So these and all parameters has to be check and we have to establish this. And next is the continual product enhancement. This is where we shouldn't leave it as it is. We have to continuously improve the product efficacy so that the product can be um, um, met with the consumer's need. Next, we have to ensure that whatever product we are giving as a sustenance development shouldn't cause any risk factor to the end consumer users. So there is many risk factors. They are classified into three types: AURA, DURA, and PURA. That is end user risk analysis, application end user risk analysis, um, process end user risk analysis, and design end user risk analysis. Now, as we as a design engineer, we work on the application and design end user risk analysis. Process is something that process engineers takes place into, and that is completely a manufacturing stream, which is also a part of our engineering sector. But we as a design engineer, we mostly work on the AURA and DURA. Okay. Shankar sir, can you move to the next slide? So, uh, before this slide, sir, there is one slide between. No, next slide. Yeah, next slide, please. Okay. So, this is how there are two types of engineering. One is forward engineering, and next one is re-engineering or reverse engineering. The forward engineering is defined based on the concept development, then manufacturing of new product and establishing into the market. And the reverse engineering is we analyze a product that is already in the market, we create a design from them, and we meet the current requirement of that particular product, meeting to the current consumer requirement. Now, this is a reverse engineering. The reverse engineering is a place where the two types of reverse engineering are there existing in the place. I can explain you it in the next slide. Sure. So, can you move to the next slide? So, next slide, please. So, next slide. Shankar sir, next slide, please. Yeah, sorry for the delay. So, this is how a reverse engineering works. We have a physical product. We obtain the dimension of the product through manual measurement or optical measurement. They call as CMM, coordinate measuring machine, or virtual monitoring machine. Through that, we establish a 3D design of the particular existing model, and next we inspect the model with the physical model where if there is any differences in the measurement that we have conducted or not. And then we work on with creating a manufacturing drawing, and then we process for manufacture. Now this is one way of doing a reverse engineering. A small twitch to this reverse engineering product can give us an output that meets the current requirement of the consumer. For example, for same product, this is only an iron box. Now we know that China is replicating every product. They use this reverse engineering concept to do that activity, and they give the product now. But for example, in this product, we need a steam to be added to this. So what can be added? At the base plate where the aluminum or steel, MS steel is used for ironing, we can use a small pores or holes, and that can be connected to a streaming function which will provide us a steam iron instead of a normal iron box. So this, like this, we can have incorporate a small design change which will not affect the product efficacy, but instead it will enhance the efficacy of the product, so that the consumer who use the current iron box may switch to a next one. So that we are working on giving a comfortable life to the consumer without risking their needs. So that's how reverse engineering comes into play. So that's why this product sustainability and reverse engineering are considered as a most crucial concept of engineering designs. Sir, can you move to the next slide? So here comes the most important part of the concept. Now, as I said, China copies and it imitates majority of the products, and in a cheaper way they commercialize it. But we, not only we as an Indian, but also in every the person who is living in every continent, we categorize our requirement not only based on cost, but also on safety, but also on efficacy. We don't buy product that is in market with low efficacy and low cost. For example, many might have bought 200 rupees headset. What would have you felt? You could have used for 2 months, 3 months, hardly. And then what happens? One side it fails, another side it fails, total product is lost. Your cost is 300, you have used it, and it gives you a pain in your ear when you use it. So all these are the hiccups that comes as a part of using a low branded, um, a non-branded product like a China product. Now the same you use headset of Bolt or Boat or Sony, they have a brand. Now, what difference do you get from them? You can get a better feeling while you hearing that next one. It doesn't repairs up because they also have a guaranteed warranty for that. Sorry, they have warranty for that, and so in that way, even the cost is high. You go for a branded part where you get your efficacy of that. You get a perfect feel of that product without risking your safety. Now, what is the difference between this non-branded part and branded part? This branded part establish their design and have it patented to their organization, such that these designs cannot be copied by any other, or they cannot be commercialized into the market by using this design. So this patent protection law, this is available in all the countries of the world. For India, it has its own, but in general, ISO, International Standard Organization, has created a regulatory to meet this requirement, and that has to be governed. As an engineer, we have to be more specific on not copying much of a thing, but we have to innovate things in such a way that it will accommodate in the patent law. The patent, what patent does is it it has lots of patenting designs. For simple product, for example, a connector is used to connect two pipes. What happens? what is the use of that connector? The connector shouldn't leak the product outside during the connection process. So that is the requirement. Based on that, a new connector design is made. The connector, the patent analyzes this design that you have made, and it will compare with all the existing patent designs that is there, and if there is any similarity, they will disown this product for patent. If there is no similarity and it has a new design, then it will allow for further patenting of that product. By doing that, your organization can claim that my product is patented, you cannot copy. If any manufacturing company uses this specific design that has already been patented, the organization which has this patent can issue a, law action against the manufacturer who has implicated the design to commercialize in the market against the knowledge of that particular organization. So in this way, the China brand, they don't have much of a patent on major of the products that they establish into the market. They just give it a fake name and they provide it to the market. But the branded guys, they provide us the brand with perfect, and that is why the cost of the product is high. If you see the manufacturing of a product, all will be the same. The China manufacturers and normal manufacturing technology uses, everyone uses the same manufacturing. The cost of manufacturing is same. The brand is what makes the cost higher, and the brand implies the patent, and the patent cost is high. So nearly about after, and also there is a limitation. You can have a patent rights for 20 years, and if the patent is a life risking one and it is more crucial to life, then it has a patent extension of 50 years. So these are all the more detailed concepts of patent and laws and enforcements. This comes under the regulatory compliance of every ISO requirements, and for particular design of a product, we work on that sector. So the few products that are shown below are products from Thermo Fisher Groups, the company which I work for, and so these are the products requirement. Now, as you can see, the patent and ISO requirement is not only limited to medical field but also to manufacturing, and every stream follows it. So the ISO is a governance body that governs the administration of that particular requirement. It might be even our college has the ISO degrees, ISO documentation works, and certificates for ISO. Likewise, it, ISO is not limited to a certain field. It is on all whole. It is for the welfare of the people, the end consumer of the people. So this concept is for everyone. So as an engineer, we have to incorporate our design, our methodologies, our expertise over in a field such a way that we have to incorporate all these factors of safety, comfortability, efficacy, and cost reduction, and less resource usefulness on improving a design to meet the customer requirement. So can we go to the next slide? So this is life isn't about finding yourself, it's about creating yourself, is what being said by George Bernard Shaw, who is a Irish politics person. um, so you have to have a goal to do something so that you can create something out of you. Now, we as an engineer, we have been expected a lot, not only from our parents, our society, our neighbors, everyone expects a lot. At a certain point, we feel that why do everyone expect a lot from us? But as time proceeds, you will get to know that these expectations are set for you so that you can build or create something for yourself. So basically, without any goal, you cannot do anything at all. So if you don't have any goal as of now, I would request, because I know that no one likes to get advice from, and specifically I too have been in the spot where you are now. So I too don't like being advised to, but I can request and I can plead to you that build a goal for yourself, build something and create for yourself so that not only your parents but the society can also be proud of you. And with that, I'd like to thank once again for giving me this opportunity to discuss on this topic. And if you have any questions, you can reach me. Thank you. Shankar sir, we can move on to the next slide, sir. It's over.
Participants, do you have any question? Okay, sir. No questions from participants. Thank you, sir.
Yeah, thank you, sir.
I am Shankar, Assistant Professor, Mechanical Department, King's College of Engineering. I am very happy to deliver the vote of thanks on this webinar. On behalf of Department of Mechanical Engineering, I would like to thank Chief Guest Mr. K. Gunasekaran for his excellent lecture on sustainability in product development. And I especially thank the management for providing facilities to conduct this webinar. And I thank Dr. R. Rajendran, Secretary, King's College of Engineering, for his continuous support to conduct this event. And I thank our principal, Dr. J. Arpuda Vijayachuli Madam, for her wonderful guidance. And I would also like to thank Vice Principal Sir, all HODs, faculty members, and participants. Once again, I thank you all for making this webinar great success.